So now we're going to talk about the makeup of options and how they come to their price. We'll take our first example. We're going to take a look at a call option and soybean options. So in this example, the call we're going to look at is the $13 call. And people tell us, by looking at the newspaper, looking at the CME website, that call is 65 cents. Now, as we went before on the size of the contract that you can find on the CME, 65 cents times 5,000 bushels equals $3,250. That's what that option will cost you in real money. But there's components to this that make this not as it's more palatable to understand that $3,250 is not money out the window. This futures price associated with those calls is $13.25. So the makeup of that call is intrinsic value plus time value equals 65 cents. Everyone understand that. The two components are intrinsic value plus time value, and the two of them combined equal the price of your option, which is 65 cents. So what is intrinsic value? Intrinsic value is the amount that this option is in the money. It may not be in the money, but in my example, it is. So what is that component? In this case, the call option is the strike price, which of $13 is below the futures price of $13.25. So the difference between the strike price and the futures price is the amount that option is in the money. And in our case, that would be 25 cents. If you take $13.25 minus the strike price, you get 25 cents. So now we have one component of this option. We know that the intrinsic value is 25 cents. So if we write that down and we write intrinsic value equals 25 cents, time value we do not know yet, total value we do know. The total value in our first example was 65 cents. We know the intrinsic value plus the time value equals 65 cents. So now we know what the time value is. The time value is 40 cents. Now, this is what you're buying actually. This 40 cents is what you're buying. The intrinsic value, as long as the futures stay there, will never change. It's always going to be 25 cents, whether it's now, July, September, November, until that option expires, you're going to get that $1,250 back based on the option being in the money by 25 cents. How did I come up with $1,250? The same way I came up with 65 cents equals $3,250. The 25 cents of intrinsic value multiplied by 5,000 bushels will give you $1,250 back of your $3,250. So the actual amount of money being spent on this option is 40 cents times 5,000 bushels equals $2,000. That's how much that option is actually going to cost you. And that part of the option is going to ebb and flow all day long based on market movement, based on time decay, and based on volatility. So let's take a look at that. One of the things that we really have to understand is delta. Now, delta is the amount of the probability that option is going to be in the money. When we talked about our value of this call option, the intrinsic value says that it's in the money. So that delta on that call is going to be greater than 50% because it's already in the money. And based on how much time is left, the time value component will set that delta also. Over the course of time, with this option being in the money, that delta will increase to 100. 100 being that is the exact same as a future. And if you think about that, all the way to expiration, you have the right but not the obligation to buy that underlying commodity. If we get to the day of expiration, where the contracts have to be settled, our call will be exercised because it's a $13 strike price versus a $13.25 futures price. We will turn that into a future because we don't want to give away that 25 cents. So that delta of 100 turns that call into a future. With a lot of time left, with a year to go, that movement can move in and out of $13 and go to $12.90, it can go to $14, it can go to $11.70. So that delta is always moving because we're not going to want to exercise that call option if the futures prices are $11.70. At $11.70, it's no longer in the money. It is out of the money, and you will not want to be buying soybeans at $13. You will not exercise that right to buy them, not the obligation, at $13 if the actual price is $11.70. It just doesn't make economical sense. But as it goes up, you do have the right, but not the obligation, to buy that underlying commodity at $13 if we're trading something at over $13. $14 for sure, $15 even greater. If we go to $20, you have the right to buy those soybeans at $13 plus the amount of money that you pay for those options. That's the nice thing about options. When you buy them, you're limited to the amount of money that you spent on your loss. You can only lose what you pay for them. So you have unlimited profitability and limited liability. Whereas the seller of those options has limited profitability, the 40 cents he sold them to you for, and unlimited liability. If it goes to $16, $17, $18, he's out the difference between the strike price and the futures price minus what he took in for those. He can only make $2,000. That's it. That doesn't mean that selling options is not profitable. Selling options can be very profitable, but you need to know when they're expensive. And that is what we're going to teach you. That's what traders know. And that's what quite frankly, you farmers are told by your brokers, buy puts. If you're not buying them at the right time, that's not what you want to do. And there are lots and lots of ways to be able to hedge your product without just buying puts. And that's what we're going to figure out. But first, we have to understand the makeup of these options. So let's go back to our example of how an option is made up. We have intrinsic value plus time value equals the price of the option. Now I'm going to show you something really cool. We're going to look at the $13 call. We're going to just keep our same example because I don't want to get into too many different examples because it just gets confusing. And if you understand one, I can give you, and we will do this, I can give you all different kinds of examples and you're going to understand it. So let's just stick with the $13 soybean call or strike price and a $13.25 futures price. Now watch this. So the futures are $13.25, and the call is 65 cents. And we know that that call is made up of 25 cents of intrinsic value and 40 cents of time value. Now, we talked about delta, okay? The delta on that call is going to be greater than 50 because it's already in the money. So the greater chance, the greater probability that that option is going to be in the money because it already is, than it is to be out of the money. But let's take a look at the put. People don't like puts because they're hard to understand. But after you get through this course, they're not going to be hard to understand. And you'll probably like them more than you like calls because nobody knows how to price them as well. So put option. A put option's got the exact same makeup as a call option. It's got intrinsic value and time value. Now, we don't know what that put option is. No one's told us. All we know is it's got intrinsic value plus time value. And we're talking about the $13 put, the same as the $13 call. They're the same strike price, okay? Now, the $13 call has intrinsic value of 25 cents. We went over that before. The amount of money that the option is in the money versus the futures price, the strike price versus the futures price. So in the call, When the call strike price is below the futures price, that has intrinsic value. The put, let's take a look at this $13 put. How much intrinsic value is in the $13 put? What is intrinsic value? Again, I keep saying it over and over again. And the reason I do that is so that it becomes second nature for you. Intrinsic value is the amount of money that option is in the money. So let's make it simple. If soybeans are trading $13.25, would you want the right, but not the obligation? Or so let me rephrase that. Would you want the obligation to sell futures at $13 if the market rate was $13.25? Hopefully by now, the answer to that question is no, zero. I would not want to sell soybeans at $13 if I knew I could sell them at $13.25. Because I don't want to give away 25 cents. That 25 cents is the intrinsic value of the call. But the put, the same strike price put, has no intrinsic value. It's not in the money. It is what we call out of the money. And that's what most of these options are traded. Very few in the money options are traded. Unless they're already in your portfolio, you're not going to trade them. So when people start talking about what option you want to hedge your portfolio with, it's going to be out of the money options because nobody wants to pay for that intrinsic, have that on their books. It just doesn't make any sense because this is what I'm going to show you. I'm going to show you that the call and the put in the same strike are the exact same thing. We don't need to trade the $13 call when we can trade the $13 put and turn it into a call. I'm getting ahead of myself a little bit, but this is the exciting part that I get really excited about, is that most people don't understand it. But when you do understand it, the light will go off and like, yeah, now I get it. So let's go back in time. So we talked about this $13 put value. So we have no intrinsic value for this put. The intrinsic value is zero. It's not in the money. It's out of the money. Any out of the money option has zero intrinsic value. It's not part of the definition of what intrinsic value is. I keep going over it and over it again, but it's very, very important. Intrinsic value is just the amount of money that option is in the money. That does not mean that puts do not have intrinsic value. In our next example, I'm going to show you where the put does have intrinsic value. In our example right now, it has no intrinsic value. So you're going to say to me, Brian, okay, the put has no intrinsic value. How am I going to determine how much this thing is worth? It's only time value. Time value is subjective. No, not really. What I'm going to tell you now, you got to keep a secret. The time value in the call and the put in the same strike are the same, always and forever. That's just the way options work. So now a light went off in your head and you said, well, how much time value is there? Well, some people are saying, I still understand what you're saying. Where's the time value? The time value and the call and the put are exactly the same. So let's look back. What is the time value in our call? Actually, let's even look further back. What is the value of our call? It's 65 cents. That didn't change. But the makeup of that call, as we went through it before, is made up of intrinsic value plus time value. The intrinsic value we determined was 25 cents, which left only 40 cents for the time value. Now, what I told you before is going to resonate. The time value and the call and the put in the same strike. That's really important. It can't be different strikes. It has to be the same strike. But the time value and the call and the put in the same strike are exactly the same all the time. So, in our example, we backed into how much time value was in the call based on how much intrinsic value was on the futures price minus the strike price. And we came up with 40 cents. So, how much time value is in the put? If you said 40 cents, you're exactly right. That's exactly what the time value is. The time value in the call and the put are exactly the same. The call is 25 cents of intrinsic value, 40 cents of time value. The total value is 65 cents. The put, it's not in the money. I don't want to sell soybeans at $13 when I can sell them at $13.25. So it is out of the money. There is no intrinsic value. So 0 plus time value gives me the price of the put. Now, calls and puts in the same strike have the same time value, which is why I know that the time value is 40 cents in the put. Now, this is where things get really interesting, and this is where pit traders made a lot of money. This is called an arbitrage, and an arbitrage exists when there's a mispriced option. So if we're trading $13.25, and you know that you can buy or sell futures, that's kind of important. If you know you can buy or sell futures at that price without moving the market, and someone came in and asked for the $13 call, and so the fair market value was 65 cents. And then they came in and asked just for the put, and someone came in and said they would sell it at 35 cents. You know, because of what we just talked about, that is an arbitrage edge. You can buy those puts for 35 cents knowing they have 40 cents of time value. That's really cool. And that's how a lot of pit traders made a lot of money. And that's all they did all day long, is they arbitraged that 40 cents. And it wasn't 35 cents. Nothing got that wide. But it would be 39.5, 40.5. When I say that, 39.5, 40.5, what does that mean? It means I'll pay 39.5 cents if you want to sell them to me, and I'll sell them to you at 40.5 cents. That is what pit traders did all day long. That's what a market maker is. And that's how they made money. They didn't care if they're buying or selling. They didn't even know if they're going to be buying or selling. They just made a two-sided market around fair value of that time value. The time value is really, really important. The intrinsic value is just there. The time value is what all people trade. When we get into what changes the price of these options, most of it is going to be associated with the time value. The intrinsic value will only change based on the futures movement. That's it. It doesn't change over time. It doesn't change with volatility. That's not a component of the option that's going to be subject to subjectivity. Okay. We've gone through the basic component of what makes up the price of an option. We're going to find out later on what changes the price of that option based on the Greeks that we define in section 1, the delta, the gamma, the vega, and the theta. What I want to discuss now is delta. And what I really want you to understand with this is the array of the options that we trade and the amount of time that you're using to trade them, how that affects the delta. So when we talk about delta, let's define it again first. The delta is the probability that option will go into the money by the time it expires. I like to look at an array of options on a component, as I'm writing down here. And we always tie everything to where the futures are. Let's keep things simple, okay? Let's keep things with $13. And this time I'm going to use $13. Now I'm going to use the calls on the top side and puts on the downside, okay? And $13 strike price, and we'll call this the $16 strike price, and we'll call this the $8 strike price. So we've got 12, 10. This is obviously not to scale, but you get the idea. 14, 15, 16. Okay, so we've got calls on the top and puts on the bottom. Now, if the futures are $13 and I put the gun to your head and I say the next tick determines which one is in the money. Again, in the money, out of the money, and at the money. And that's what we're going to do here. We're going to show you in the money, out of the money, and at the money. Right now, this is what we call at the money, because the $13 strike price is exactly the same as the futures price. So you're going to hear those things a lot. Are those at the money options? Are those out of the money options? Are those in the money options? Right now, we're talking about the $13 call and put, and the futures are exactly $13. That happens a lot. You're going to see it quite a bit. And you always want to look at the money. When you hear people talk about the other components that make up the price of an option, like volatility, that's going to be your reference. You want to reference the at the money option to determine what the volatility is. In this case right now, we're talking about delta. Okay? Delta is the probability that an option will go in the money. Now, again, I'm putting the gun to your head. You can either have the $13 call or the $13 put. Which one do you want? This gets a little bit frustrating as a trader because a lot of people are going to say the call. More people will say the call than the put. And it gets frustrating because they're exactly the same. You do not know which tick is next. Is it 1301 or is it 1299? It's a coin flip. You don't know. It's impossible to know. So to say you'd rather have the call option over the put option is, it doesn't make any sense because they're the same. But people are so familiar with call options and they're so afraid of put options, they automatically think, well, there's a better chance that it goes up. That's not true. It's a 50-50 chance. Now, what I just said there is important. 50-50. There's a 50% probability that the next tick is going to be up and the call will go in the money. There's a 50% probability that it'll go down and the put will be in the money. That 50-50 is the delta. Okay. So we understand that at the money options have a 50 delta in the call and a 50 delta in the put. If you add those two together, what does that come up to? It comes up to 100 or 1. That is the delta of a future. The probability that the future is going to be in the money is 1. It's 100%. It's a future. The probability that's going to be on the money is 0. It's a future. It's got a delta of 100. There is no way around it. But what is really neat is that when we add the call and put delta in the same strike, they're going to add up to a future. That's going to be very important for section 2. When we start to go a little bit further and deeper into what we're doing here, you're going to have to really, really pay attention to that. I'm going to say it again. The delta in the call and the put in the same strike always add up to 100. Not less, not more, 100. So let's take a look at our array here. If we were to look at the $12 call with the futures of $13, and I put the gun to your head and I said, you can either have the $12 call today or the $12 put. Which one is it? Now you can tell me the $12 call because it's already in the money by $1. That has a higher probability that the next tick is going to keep that thing in the money than go out of the money. At $13, if it goes to $13.01, it's still in the money. If it goes to $12.99, it's still in the money. It's a delta of greater than 50. I don't know the exact delta on that call right now because there's a lot of things that go into it, and that was the pricing model that we talked about in section 1, the Black-Scholes and Whaley models. So for our purposes, I'm just going to assign it a delta of 60. If that delta on that call is 60, what would the delta on the put be? Well, we know that the delta of the call and the put in the same strike is 100. If the delta on the call is 60, the put has to be 40. So what this is saying is that at this snapshot in time, the call has a 60% chance of being in the money at expiration. Now, if that expiration is in November, that makes a lot of sense because there's a lot that can happen between now and November. There's a 40% chance that that put could go in the money between now and December. If we go further down the array that I have, you can see that the call delta is going to increase. So the $10 call with futures at $13 is going to have a higher delta than 50. It's going to have a higher delta than 60 because the next tick from $10 with the strike price of $10 and the futures of $13 is not going to affect that probability very much at all. So let's assign that an 80 delta. So the further you go down, the delta increases in the call. What does it do in the put? It decreases. And why does it decrease? Because the call and put delta have to equal 100. So the $10 put has a delta of 20. How did I get that? Same way I did when we're at $13. At $13 is a 50-50 chance. They add up to 100. The delta on the $10 calls is 80. Then the delta of the $10 put has to be 20. If we keep going down in strike price, down to the $8, we'll find a probability that the $8 puts are going to be in the money gets very, very small. Let's say that chance of it happening is 5. The delta on the put is 5. What does that put the delta of the call? Well, we know what it is because we're in this course. The delta of that call is 95. 95 plus 5 equals 100. 80 plus 20 equals 100. 60 plus 40 equals 100. 50 plus 50 equals 100. Now let's go the other way. And people don't like this way because people don't like puts. I love them. So the $14 calls with the futures at $13 calls, they're out of the money. What is the probability that that next tick is going to put that $14 call in the money? Not so great. The more time we have, the greater chance there is. So let's assign that the same delta that our $12 put had. We'll assign that a 40 delta on the call. Just like the $12 put had a 40 delta, the $14 call has a 40 delta. The reason I picked that is because they're both $1 away from at the money. Futures prices are $13. The $13 strike price is a 50 delta. A $13 put is a 50 delta. In our arbitrary assignment of deltas, we assign the $12 put, which is $1 out of the money. From $13, the $12 put is $1 out of the money. We assign that 40. That's why I assigned the $14 call a delta of 40. It's the same out of the money. Same sort of probability that that option will go into the money that the $12 put does. The thing that's really important is what is the delta of the $14 put? If the $14 call is 40, well, we know that that is 60. And why do we know that? Because the call and put in the same strike have to equal 100. I keep repeating myself and I sound like a broken record. The reason I do that is so it resonates and that it's very important. So as we go up the array, the $15 call has a delta of 70. Sorry, the put has a delta of 70. The call has a delta of 30. And then the further up we go, the $16 call have a delta of 20. The put has a delta of 80. To the point where we'll go up to like the $19 call has a delta of 5, and the put is a delta of 95. That is delta. That array is delta. And if it helps you to write that down before you even every morning so you can see your array and understand that the more in the money the call is, the higher the delta. The more in the money the put is, the higher the delta, then do it. That's a really good way of just visually looking at it and say, yes, I understand that the further out of the money call is going to have a smaller delta than the closer to the out of the money calls. What I mean by that is take a look at the $15 call versus the $14 call. These options are both out of the money. Even though the $14 call has a 40% chance of being in the money, the $15 call has a 30% chance of being in the money. That should make sense to people because it can't go to $15 before it goes to $14. So the $14 call has to have a larger probability of going in the money than the $15 call all the time. It has to go through 14 before it can get to 15. If somebody tells you that the $15 call has a delta higher than the $14 call, just tell them they're wrong. Tell them that you know, because tell them that you are now a trading commodity option guru, because it cannot happen. The same on the downside. The $12 put has a delta of 40. The $10 put has a delta of 20. You can't go to $10 without going through $12 first. So the $12 put is always going to have a higher delta than the $10 put. And when you map out your array here, you can see it's always that way. The further out of the money put, the smaller the delta. The further out of the money call, the smaller delta. So the smaller the options are, the smaller the delta is. Okay, now that we've discussed delta and we've got a fairly firm handle on delta, trust me, this doesn't come that easy where I tell you one time and all of a sudden it's like, it's super easy. It's not super easy. But the more and more we talk about it, the more and more we use it, the more and more comfortable you'll get with it, and the more and more it'll be second nature to you. So we're going to do a couple of examples now, okay? We're going to take call and put. I'm going to graph it out for you so you can see what it looks like. We're going to go back and we're going to do the whole thing all over again. We're going to do intrinsic value plus time value equals the option. And I'm going to graph everything out for you with strike prices and everything. So it's going to look really, really nice and easy on this graph, hopefully. So what we're going to do now, let's take futures at $13. I like doing that. I like even number futures because it's easy to figure out. So we'll take futures at $13. Now we're going to take out of the money options because that's what's traded the most and it's the easiest for us to graph out. So we're going to take the $14 call first. The $14 call in our example is going to be worth 10 cents. So let's take a look at that. $14 call equals 10 cents. $14 call equals intrinsic value plus time value. Now, I wish somebody was in the room so I could ask what the intrinsic value of a $14 call is with the futures at $13. Because I know that everybody in my class will be throwing up their hand saying the number 0. Because what is intrinsic value? Intrinsic value is the amount that an option is in the money. And in our case, $14 is not in the money. We are not willing to buy soybeans at $14 when we can actively buy them in the market for $13. It's like a car. Would you want to pay $60,000 for a car when someone else is selling the same car for $50,000? You don't have to. No, that you would not exercise your option to buy that car for $60,000. In our case, we have a soybean call to the option to buy soybeans futures at $14. It still costs us money. Why does it cost us money? Because there's time left. There's still a probability that that option could go in the money. Wait a minute. What did I just say? Probability? When I see the word probability, as a trader, what do I think of? I think of delta. So there's still delta to this call. There's still a probability that that call can go into the money. And that right now, we have intrinsic value plus time value. That 10 cents is what we have in time value for that option. We have 0 intrinsic plus 10 cents of time value. So now let's take a look on our little graph about what a call option looks like. Okay, so we have strike prices. We have $14, we have $13, we have $12, we have $11, we have $15, $16. Okay, then we have profits and loss. So I'm going to turn this into in dollars and cents for you guys, because a lot of times you'd like to see exactly how much money it costs. So when we take this 10 cents, what do we do again? We take 10 cents times the contract size. The contract size is what again? That's right. It's a train car. How much does it fit? How much grain fits in a train car? Oh yeah, 5,000 bushels. So we've got 10 cents times 5,000 bushels. That equals $500. The most, when you buy this option, the most you can make is the most you can lose is $500. The most the seller can make is also $500. So if you take the look at $11, would you want the option would you exercise that option to buy soybeans at $14? No, you wouldn't. Would you want the option to buy them at $12? No, you wouldn't. You'd still lose your $500. At $13, do you want to exercise your option? No, you wouldn't. At $14, would you want to exercise that option to buy soybean futures? Now it's getting interesting. Yes, you would. At $15, would you want to exercise that option to buy futures? Yes, you would. At $16, so on and so on. The graph that I just drawn for you is a graph of what a long call looks like. Now, why did I not cross right at $14? Well, that is simple. That price, where you break even, is $14.10. Why is it $14.10? Because you paid 10 cents for the right to buy futures at $14. So your actual price is $14.10 where you break even. Everything above $14.10, as you can see on our graph, is profit. And the higher we go in futures price, the more profit you make. If we look at this profit and loss, this is not to scale, obviously, but it could be as high as, $15,000 you could make on that option. In order for that to happen, it would have to be $3 of the money. So it would be $17. This, if you did all the way across and took it down, that would be $17, would be $15,000. Again, how did I come up with $15,000? It's the exact same way that I came up with 10 cents. It's $3 in money, $17 minus $14. By the way, in the money, if it's $17 to $14 in the money, $14 call has intrinsic value now. Intrinsic value is the amount of money that an option is in the money. In our case, on this rally, we have $3 of intrinsic value. $3 of profit for you, and $3 of profit times 5,000 bushels is $15,000 a contract. So that's what a call option looks like graphed out. Now we're going to look at the puts. Again, nobody likes puts. I love them. And we're going to look at these $11 puts. They're out of the money by quite a bit since the futures are trading $13. So when we look at the price of that put as being 5 cents, again, that's 5 cents times 5,000 bushels equals $250. That's what your loss is when you buy them, and you can lose no more. And when the futures are above $11, you're not going to want to exercise your option, but not your obligation to sell soybeans at $11. Not when they're trading 15, 16, 17, 13, not even if they're $11.15, not even if they're $11.01. You're not going to want to exercise that until your option goes in the money. And that's when you want to turn it into a future. So if you look at our graph here, the graph of a long put, the higher the strike price, you still lose $250, no matter where we are. $17, $20, $30, infinity. You only lose $250. Until we start getting down in strike prices, does it start to get more interesting. And then you start making money. And when it crosses your axis, that red line is what a long put looks like. So you can see that it crosses at $11. And like the call, your strike price is important, but that's not your total cost, because you paid 5 cents for the right to make that trade and sell the soybeans at $11. So your price is actually at $10.95. Whereas on the call side, your price was $14.10. You can see that your profitability didn't start going up until you recouped your costs back. In the call, that was $500, and the put, that was $250.